We're continuing with multiplying, or rather dividing, I should say, roots, and we're going to see that this is where it gets a little strange. So there isn't any real way to divide 4 by a square root unless you were using your calculator. But the math approach is something called rationalizing the denominator. What we do is we don't want there to be a root in the bottom, and this is our equivalent of division. So it's a little strange here, but what we're doing, we're going to multiply the top and the bottom by the square root of 3. Now this is legal because the square root of 3 times the square root of 3, like over the square root of 3 rather, it's 1. So I haven't broken any rules. And what this accomplishes is you see that it is going to allow the bottom to no longer be a root. This is the best we can do as we move forward in college algebra, is we just get rid of the root on the bottom because there's no other way to divide it. And so what we do, it's called rationalizing the denominator. Again, the trick is the same root over itself is 1. So then we can just multiply the tops and multiply the bottoms. Okay, easy trick here. I'll show you one before maybe you want to pause it and try on your own. So I'm choosing the square root of 3 over itself. There's nothing wrong with that. It's still 1. And I would get the 5 square root of 3 over 3. Okay, same idea here. We've just changed it to the square root of 5. So the top I get 6 square root of 5. Now it's 5. So we're rationalizing the denominator. Now it gets a little more complicated here, but the premise is the same. The issue is the square root of 6. So I'm just going to multiply the top and the bottom by that square root of 6. Oh yeah, we jumped here. I'm not sure what they're doing. This is what you would get next. Yeah, they're just reducing here. Yeah. So I would have shown it to you like you get 8 square root of 6 over 18. Now they went ahead and saw that these are both divisible by 2, so they divided that out to reduce it. And we got this. Okay, so we're just going to do the square root of 5 because that's the problem part. And we would have 5 square root of 5 over 2 times 5, which would be 10. Now, I'll show it to you like this. So you have a common factor. The 5's could go. And I'm left with the square root of 5 over 2. Right, here's another one. Square root of 3 over the square root of 3. We're going to rationalize that. So the bottom is now 4 times 3, or 12. Now, you don't have to show this, but I'm just going to show you there's a common factor. They share 3. So my final answer is going to be this. All right, here we're going to use our trick that we saw in the last video where I'm allowed to separate this into 2 different roots. And the reason I'm going to, well, first I would have checked to see if I could simplify underneath that root, but I can't. So I'm going to use that trick to separate it. Now, the only one that's a problem is I don't want a root in the denominator. Well, hold on. They simplified that first, which is going to make it easier. The square root of 12 can break down into 2 square root of 3. Now, the square root of 3 is the only one that matters. I don't care about the top. It's just the bottom that I don't want a root. So I multiply the top and the bottom by the square root of 3. I get the square root of 15 over 6. All right, let's do this again. Now, I would check to see if this reduces if it was a more complicated problem, but it doesn't. So I'm going to then break it into the 2 individual roots. Now, hopefully you're comfortable with this. If not, go back to an old video. But this is going to wind up being 3 square root of 2. Okay, now the square root of 2 is the only problem part, so I'm going to just rationalize that. So the bottom is now 3 times 2. I get square root of 14 over 6. Now, Double checking to make sure that on the top couldn't be simplified, but it doesn't. And I'm done. All right, I would check to simplify, but I can't. So try this on your own if you want to. Break it into 2. Okay, now the bottom needs to be simplified. I'm trying to think of 16. So it's going to be this. You can do the long way if you don't see how I got there. Okay, now the problem on the bottom is I don't want a square root of 2, so I'm going to rationalize that. Now top times top is going to give me the square root of 6. Bottom times bottom is going to give me 4 times 2, or 8. You see, this makes the 2. 4 times 2 would then be 8. Okay, I checked to see if that square root of 6 can be simplified, but it can't. And that's my final answer. Okay, let me see if I can tell. I don't know. Yeah, I don't see anything different about this. They broke it into 2. They simplified the denominator. Then they rationalized it. And that's it. Just bigger numbers, but I don't see anything else that changes anything. Okay, this one though. So first I would have seen, maybe that's what they were doing. Hold on. So let's do before I can break this down, this one does simplify. So I'm going to do that. And now I have the square root of 1 over 9. What have I done? Am I right about that? Yeah, I don't know where they're going with this because this one simplifies right away. So yeah, that's it. So now by simplifying it right at the beginning, it becomes like a question from our last section. And now I'm going to break it back into my square roots, and I'm going to get 1 over 3. I'm not sure if that's what they intended. Maybe it is. What are they doing here? Okay, so I can simplify this. Okay, I'm going to simplify this, and the 10s would cancel. So I am left with 1 over 5 in there. Okay, now this will be a little bit more like what I would expect. Now let's break that into individual square roots. Now the top, square root of 1 is just 1. But I'm left with a square root of 5 on the bottom, so I have to rationalize that. There's our trick again. Leaves me with the square root of 5 over 5. Okay, now we've got a more challenging section with rationalizing the denominators next, but that should be a good introduction.